Imagine a world where the deadliest predator was not a dinosaur, but a tiny insect. For over 100 million years, these creatures have outlived every major mass extinction event. They survived ice ages, volcanic winters, and asteroid impacts that wiped out everything else. Their resilience is unmatched in the history of life on Earth, surviving 5 near-total extinctions. Yet, their biggest challenge was not a natural disaster, but the evolution of human ingenuity. It started with a simple invention in 1946, a chemical spray that changed the survival game forever. Before this, ancient humans were defenseless against these relentless, blood-seeking airborne swarms. They had no screens, no medicine, and no understanding of the tiny killers surrounding them. How did our ancestors manage to survive alongside such a lethal and persistent creature? The answer lies in the deep, accumulated wisdom of early human survival strategies. Estimates suggest that over 50 billion human deaths were caused by mosquito-borne diseases throughout history. This staggering statistic is not an exaggeration, but a grim reality of our shared past. Roughly half of all humans who ever lived may have been killed by this tiny insect. It is the most lethal animal in human history, far deadlier than any lion or shark. It holds the top spot by such a wide margin that others are barely worth mentioning. The secret to our survival was not a single discovery, but a complex tapestry of adaptations. Geography, fire, mud, and even our own DNA played crucial roles in our defense. In a dramatic twist, a tiny insect actually influenced the map of human civilization across Africa. Let us journey back to the beginning to understand this ancient, ongoing battle. Originally, these insects did not target humans, as we were not even part of the menu. When they first evolved, they were busy feeding on the diverse prehistoric reptiles of the Cretaceous period. Their menu back then was entirely different, consisting of large, slow-moving prehistoric creatures. Dinosaurs were their primary targets, long before humans ever walked the Earth. Fossilized remains confirm they were biting vertebrates millions of years ago. Their presence in ancient swamps is well documented in amber fossils found around the world. These preserved insects are direct evidence of their long, parasitic relationship with vertebrates. The oldest confirmed fossils date back 100 million years, showcasing their incredible longevity.
They survived the asteroid impact 66 million years ago, likely due to their aquatic larvae.
Their ability to persist through such extreme environmental collapses is truly impressive. It is important to note that only female mosquitoes bite, as they require blood for eggs. Males feed entirely on plant nectar and are completely harmless to humans. Females need the proteins in blood to develop their eggs, making it a reproductive necessity. It is not about hunger, but the survival of their future offspring. Every bite you receive is just a mother trying to provide for her children.
This insight might not stop the itching, but it clarifies their intent.
She is not attacking you. She is merely utilizing you as a resource. She has no personal feelings about it, just a biological drive to continue her line. For most of their existence, humans were not on their menu at all. The shift to targeting us happened recently, driven by our unique chemical signature. Humans emit a cocktail of body odors, carbon dioxide, and heat that attracts them. To a female mosquito, we are a distinct and highly desirable meal. We smell like a gourmet feast from a very long distance away. Recent genetic studies show this preference evolved around 1.8 million years ago. This coincides with the rise of early human ancestors in that specific region. They adapted to prefer human blood because we were suddenly everywhere. Their olfactory system evolved to detect our specific human scent markers. We showed up, we smelled interesting, and they adapted to exploit us. We have been paying for that evolutionary miscalculation ever since. They are masters at finding us, even when we try to hide. They have redundant sensory systems to ensure they never lose our scent. They evolved multiple backups, making it nearly impossible to avoid them completely.
We inspired their level of engineering, and we did not even have a choice. This map shows the current distribution of the insects. The green zones are where the highest concentrations are found.
This avoidance was a crucial part of our survival strategy. The overlap between our habitats and theirs was historically very minimal. We simply did not live where they were most active.
Where they were densest, we were scarce, and vice versa.
We learned to choose safer, drier locations for our settlements.
This was not a conscious decision, but a result of generations of experience.
It was an avoidance behavior, passed down through cultural storytelling.
They knew which paths to take and which swamps to avoid. The swamp was a death trap, and they knew it. They stayed away, protecting their families and their future. This collective wisdom was the key to our survival for thousands of years. No individual understood the science, but the community knew the danger. They taught their children to respect the invisible boundaries of nature.
Knowledge was passed through stories, not textbooks.
They didn't need records to know that the swamp kills. They learned by watching the consequences of ignoring the lessons. A simple night near the marsh could change everything. One bad choice in water source could devastate a village.
The rainy season brought the swarms, and the losses were immense.
You don't need to be a doctor to know the valley kills.
The lesson was encoded in stories, a warning for all.
Stay on the high ground, and you might just survive.
This simple rule is one of the oldest pieces of public health knowledge.